Hello everyone, this is Prakash and we are starting with a new series. Hope you will enjoy this video. Alright, let's start. So, in this video, we'll be discussing two simplest metrics used in machine learning, and many of us, like 90% of the learners, have a misunderstanding that R2 score and accuracy both are same, which is not real. Actually, these are two different metrics, and which we will be understanding in this video. Okay, let's start. First of all, what is accuracy? Accuracy is basically to measure the correctness of your model prediction. Like how many correct predictions are the model captured out of the total predictions, right? Accuracy is something used in classification problems. You cannot use accuracy in your regression problems. Okay, so that's the first understanding. So you should not be comparing accuracy and R2 score, right? Accuracy is used for classification problem only, and R2 score is used in regression. So let's understand what is R2 score now. R2 score is something that explain how much variance is explained by the model in the in your predictions, right? So the mathematical formula, as you can see, it's the square difference of your model prediction errors undivided by the difference of your actual value minus your mean. Like so, both accuracy and R2 score have different meanings. Now, let's have a bit by bit comparison between accuracy and R2 score. So use case for accuracy, it is predict the discrete labels, right? Like spam or not spam, whether you have any digits or not digits, like the classification problems, right? R2 score is predicting continuous values, right? Your home price prediction or temperature or salary predictions. Look, so in R2 score, you are predicting or you are validating a continuous values. Okay, and you can see the range of accuracy is 0 to 1, and the range of R2 score, it's negativity infinity to 1. So 1 means the perfect and 0 means as good as predicting the mean, and less than 0 means it's worse than mean, right? But in case of accuracy, it 0 means all wrong, and 1 means all correct. Okay. And there is a simple analogy to how accuracy, like you cannot always use accuracy as your final metrics for evaluating a classification problems. Uh, like if you are dealing with any class imbalance data sets, like wherein you have your majority class dominating over your minority class. Uh, and let's say for an example, you are doing a classification of a rare disease like cancer. Okay, so what will happen? Like imagine you have 1,000 of patients, wherein you are having only uh, 10 actual cancer patients. Like you are having only 1% of cancer patients. So when you are training your model with this class imbalance of data set, then when the model learn the patterns, like due to the class imbalance, the majority class will dominate over your minority class, and always the model will have a correct prediction. But that one, false prediction will explain you the, and that one false prediction can miss that cancer patient. So in that way, you cannot use accuracy as your final evaluation metrics when you are dealing with a classification problem, and especially when you have class imbalance problem. Same for the weather forecast, right? For an example, um, someone is predicting that today will have no rain. So it's very obvious that always you will not have rain, right? It's specific to a season. So if somebody is predicting that today will have no rain in the summer season, then he might be correct, but actually he's just assuming that thing. It's not something that he is predicting, correct? So because of you uh, you know you are less likely to have rain in a summer season. So here you have a class imbalance situation. So in that situation or problem, you cannot use accuracy as your final model. Hope these two examples are pretty much clear for you guys. Okay, so let's now have some practical example about the R2 score. Basically, so just to save the time, I have already written the code here. I'll take weather data where we have hours of sunlight and humidity level, and our target variable is the daily temperature. So based on the sunlight and humidity level, what will be the temperature daily? So we have load the data set, then we train the split to half train data and state data, then we train the regression model, and uh, here we have taken R2 score. Okay, it's not accuracy, take it as R2 score, and here also it is R2 score. So your MSE means your root mean square. It is another matrix evaluating the model. However, in majority of cases, like for a non-technical person, we use R2 score as the evaluation matrix for the regression models or regression problems. Okay. So alone R2 score um, cannot give you the exact or correct way of evaluating a model. You can have different set of ways to evaluate a model. Like you can check the percentage of error, like how many percentage of error you are having from your actual data to your predicted data. Okay, so here I have taken the absolute percentage of error, and you can say some majority of the prediction values at the range of between uh, 2.5, okay, 3% of error is present in my majority of the predictions, and I'm having only one uh, data point wherein my error is more than 10. Okay, so in that way also you can validate your data, and you can find the optimal way how you can reduce the error wherever you are having more error, in which part. Since my data set is a small data set, and the size of the data set is 50, and the test data size will be 10. So out of 10, you can say one is having 1%, I mean 10 percentage of error. Okay. Another way of evaluating, or another metrics which is not on the paper, but you can use to have more detailed analysis about your error or evaluating the model, like percentile. So you can calculate the percentile 15 or 90th or 95 or 90, 99th percentile. So to see how many at at what percentile you are having your maximum error value. So here you can see 50th percentile error is 2.03%. So 50% of the predictions or errors are below or 2.03%. Okay, and at the last 19th percent of errors are in between the range of 11 percentage, right? So only 1% of error is more than 11%, right? Then you can see the business accuracy, which is how many predictions within 5% of error and predictions within 10% of error. So predictions of within 5% of error it's 63.64, and predictions within 10% of error is 90.91%. So the rest 10% you can identify, and you can have a better way of feature engineering or whatever technique you have to optimize the model. You can use that thing. Okay. So just to summarize, today in this video we learn about what is accuracy and how it is different from the R2 score, and in the regression problems, apart from R2 score, how you can evaluate the model in different aspects. So that's all for today. Hope you like this video. Thank you guys.